Welcome guys. Today we will learn how to make linear regression with bivariate data. We will apply some simple linear regressions with bivariate data, and we will learn how to solve this with Python and also with calculators. So first we will learn actually what is a bivariate data set. So uh, it's a pair of uh, data like x and y, and with n number of pairs. Like here, I can see I have four number of pairs x and y, and we can represent them with scatter plots. So let's check its scatter plot. So it's the scatter plot of this bivariate data, and we will learn how to determine their Bravais Pearson correlation coefficient. So to determine the Pearson correlation coefficient, first we have to know what is the covariance. There are two methods of calculating covariance. For empirical population, the covariance is the dataset of multiplication of x and y data and minus the mean of x and y divided by the number of population. And for sample, the each x data will be uh, subtracted from the x mean and multiplied by y data, each y data subtracted from the each y mean and divided by total number of sample minus 1. And we will first learn how to determine covariance of two bivariate data. So let's start with our anaconda. So I will import numpy first, and let's check an example. Uh, so I will show you solving this problem. A public outdoor swimming pool records the turnover of ice cream in euro on 7 consecutive days, as well as the rain precipitation in millimeter. So this is our x data and this is our y data. So let's write. We will take this as np.array. and then determine the mean of each numpy array. np.mean command. Now we got our mean, and we will apply the formula now. Cover, the problem number is 39. So what is the formula? Here the empirical covariance, we have to determine the empirical covariance. So we have to multiply each x and y and minus their means. So we got our result. Actually, we have used this formula with divided by 1 by n, and let's try with this formula again. with both formula of empirical covariance, we got precision up to 12 digits after decimal, so it definitely works. So we have learned how to determine our covariance with Python. So now we will learn how to determine the Bravais Pearson correlation coefficient. The Bravais Pearson correlation coefficient, or shortly we call it Pearson correlation coefficient, is an appropriate measure for the linear relationship of two variables. So actually here is the formula: the covariance of the variables divided by the multiplication of their root over a variance, or their multiple of standard deviations, and it can be ranged from -1 to +1. Sorry here. So minimum -1 and maximum +1. Uh, Positive correlation coefficient means a strong correlation between the variables. So we will perform the Bravais Pearson correlation coefficient here of the previous data. So let's start again. So we have the data here. So first we have determined our covariance. Now we will determine the standard deviation of this 2 numpy array, and then just apply the formula: the covariance divided by the multiplication of the standard deviations, and we got our result. It's minus 0.957. And also there is a direct formula for correlation coefficient, that is np.cor core corr core coef, then x data is this, or this data, and y and we will make this coefficient range from -1 to +1. So we have to perform another operation. This both variables are they will be similar, so I am changing this. Alternative. Just write the variable and make it I hope it will work. Yeah, so it works, and the precision up to almost 10 or 12 decimal points in both formula. So if we just with this formula we can directly determine our correlation coefficient, and also we can make this with our calculator. So here I have written the data in my list 3 and 4. So I am showing it from the beginning. First we have to go to the menu with Casio CG50 graphing calculator, and with this navigator I have to select statistics and then enter. Here if I make it small, then with exe go to the menu, select with this navigator the statistics and click exe. Then we will enter the statistics, and then we have to input the data. So I am making this from the beginning. So make it x. Okay, I am showing you the full process from the beginning, and then you will be used to using this calculator. So what are the datas? 0, 7, 14, 21, 25, 27, 35. Okay, now we have to set our graph set, and our graph type of base data, and we have to select our list. We can see that our list is in list 1 and list 2. So we have to click the set from here and go to down and list. So our X is list 1, exe list 1, and then our Y. So I can click the list and choose 2. Okay, and we can choose our mark type, graph color, If I see the color options, then we can select our graph color. So I am selecting the blue, and the setup is done. Then we will exit, and then graph 1. So here we can see the scatter plot of this. We can draw our regression line with this scatter plot. So the slope is downward, and the as the correlation coefficient is negative. Okay, let's check our regression plot and the A, B values and the coefficient values from here. Then click the F2 for selecting the option A plus Bx. Okay, so we got our R value minus 0.957 also, and both values are matches up to 3 decimal point in Python and calculator. Also, we are getting our R square value, our MSC values A, B. Uh, every required values are here. If we click draw by F6, and we are getting our regression line, and it's amazing. Problem is, a company manufactures a specific electronic device which is used in a very wide temperature range. Actually, there is X data and lifetime. So there is a relation between the temperature and the lifetime. So let's determine the correlation value and then perform some regression analysis. Okay, so now we will determine our A and B values with numpy polyfit or np polyfit. So slope, just our X, Y, Oh, sorry. The degree of our polynomial is 1 as it a plus bx. And now we will check slope. Slope means our a value, and intercept means our b value. So now they are asking that what lifetime can be expected given a temperature of 15 degrees Celsius based on a linear regression model. In our linear regression model, if the expected lifetime is 15 or the x value is 15, then what lifetime or what is the y value, expected y value? So let's do it in our calculator easily. So I am trying with calculator. So go to calc F2. Sorry, go to first graph 1, and it's my plot, and go to calc x. So let's try with a plus bx. So my with the a plus bx, the a value will be 476.408, and b value will be minus 5.95, and the r value is same, minus 0.996. Okay, so let's verify our correlation coefficient with Python. I'm sorry, the command is typing mistake. Okay, 0.9968. The calculator is also 0.99686. Okay, so the both results are same, and in that case, our A and B. So our A is 476.40, and our expected y will be 387.15, and the result is almost matches because of the decimal points. If we take all the decimal points of A and B, then I think the result will match more perfectly. And we can also plot the linear regression with the error bars in our Python code with matplotlib. I will attach the code in my description box, and it will work like this. And you should try in your own practice Jupyter notebook, and also the with the calculator. So we have learned how to perform linear regression with calculator and Python. See you in next videos with some new topics.